Just 6 months ago, Air Force 55118 was just a number on the production line. Then in the dark hours of the morning on June 14th, 1956, the record-breaking production run was climaxed. Now, with construction completed, North American's newest fighter bomber begins a new phase, tests. The next dozen weeks were devoted to checking the design assumptions and production methods, making doubly sure the plane was fully airworthy. Preparing for thorough examination, the crew in the stripping department gave the craft a steam bath. Characteristic painting identified it as a test vehicle and gave it a ready-to-go look. It was ready to go, but only into another hangar and into an intensive ground test program. The first item on the agenda was weighing. The engineers took its weight using a new electronic system. Strain gauges were mounted in the jacking blocks, and as they are compressed, change in resistance was read as pounds of load. At a central control station, electrical signals for each jack point were taken and translated into pounds.
The nose wheel clear?
Okay, nose gear clear.
Okay.
Both wings were raised until the gear is clear and the airplane level. Now, the sum of the load exerted at each jack was total to get empty weight.
About how much does it weigh?
Oh, about 26.5.
About how much longer are you going to be?
I'll be pretty quick.
While the scales were cleared away, the flutter and vibration crew set up their truckload of gear. Flutter during flight can be damaging, even destructive, so every effort is made to ensure that the structure is free of flutter tendencies. Shakers physically move the components, move them throughout a range of frequencies to simulate all possible flight conditions. Vibration pickups are used like a stethoscope to plot frequencies at all major stations.
We have 13 thousandths in phase. Okay, 24. We have 2.5 thousandths, 2.5 and 180 degrees. Phase reversal there.
Fuselage, wings, empennage, all components were gone over foot by foot to assure they were free of uncontrolled vibrations. Test airplanes seem to spend their lives being dismantled, then reassembled, and this plane is no exception. An external mount supports the engine while the aft fuselage is removed. The traditional 4-bolt arrangement attaches forward and aft fuselage sections. Breaking the remainder of the disconnects allows the fuselage to be rolled back, exposing the engine. A simple sling is attached, the forward mounts released, and the engine swings out of its nacelle. Initial engine test runs were made at North American Santa Susana Field Test Laboratory. Meanwhile, another crew was prepared for the next test phase as George the Dummy was unceremoniously elevated to the pilot's seat. In keeping with North American Aviation's policy of safety for the pilot, a prime effort was the testing of the emergency ejection system of the canopy. Under its protective cushions for static tests, the F-107 stood ready for the burden of proof. The canopy is a one-piece elevator type and is chain-driven on vertical tracks. A special platform protects the forward fuselage. Immediately after firing, the door on the upper surface of the platform will slide over the opening to protect the cockpit in the event the canopy breaks loose from its harness. The harness itself, mounted on the crane, allowed the canopy necessary travel in the test ejection and protected it from damage. Engineers agreed on final details. Lighting equipment was ready for high-speed cameras to visually record results of the test for critical analysis.
All right, let's get the canopy closed and we'll start now.
Okay, go ahead.
everyone please move away from the airplane?
Engineers huddled to check signals for testing the landing gear under simulated flight loads. A distinguishing feature of the landing gear is a dual-wheel nose gear retracting forward, and the main gear forward and inboard into the fuselage. Rubber shock cords attached to the main gear and nose wheel lay inert but ready for stretching to give the proper air load at each increment of the tests.
Stress band on your station. Get ready for gear up. Get ready for gear pull up. Gear pull up. 3, 2, 1, contact.
A winch took up the slack and the load was on.
Back it off. Get ready for pull down.
A reading was taken on the strain gauges and the load recorded on the oscillograph.
3, 2, 1, contact. Record off.
Record off, and the test was complete. Proof loading followed right on the heels of landing gear tests. The stress group reset the hydraulic units and prepared to load the landing gear doors. Air loads during flight are trying to pop the doors open. Hydraulic forces simulate flight loads and prove the ability of the doors to resist the forces of flight. An unusual type of pad was used for these tests. Instead of gluing the pad to the skin, the units are like vacuum cups, and when vacuum is released, they are stripped off simply and easily, leaving the skin undamaged. Cockpit controls were next in the proof loading procedure. The maximum pilot forces required for control system design were used to check the stick and rudder. A force recorder monitored all loads, and a specially designed hydraulic rig pulled the stick and depressed the rudder pedals. Maximum pilot effort was exerted in forward and aft, as well as lateral stick movements. This phase of the program required that a special store be designed and constructed to carry the necessary instrumentation for recording performance data on the airplane during its flight test. With the nose section removed, the complex instrument panel was exposed. A motion picture camera was installed to record accurate readings of flight performance for post-flight analysis. The lower shell, hung on cables, carried equipment weighing 750 pounds, and an electrically driven take-up spool raised the undershell to meet with an upper shell mounted inside the fuselage. During the actual flight tests, instrumentation in the nose section would relay performance data by means of 12 transmitting channels to a ground station. Calibration of the fuel system established two facts. First, how much fuel contained in the tanks was usable, and second, what effect fuel usage had on center of gravity movement. JP4 flows into the tanks through a single point refueling receptacle. Fuselage and wing tanks fill simultaneously, and shut-off is automatic when cells are filled to capacity. Now the airplane was weighed to determine the amount of fuel added and the exact location of the center of gravity. The airplane fuel system is used to pump the fuel into a calibrating tank, and each portion removed was weighed. Tests showed that CG remained within limits, and system flow rates were adequate for all conditions. Fuel calibration completed the tests to be accomplished at the Los Angeles plant. The crew turned to and cocooned the 107 in miles of corrugated paper. Then hoisted it aboard the truck for the 100-mile trip to Edwards Air Force Base. The trek was made early in the morning to avoid traffic congestion and undue hazard to the airframe.
Okay, we're ready to check out the splitters now. Okay, Dan, throw the spoilers full throw.
The spoiler deflector system is a new wrinkle in lateral control. The ailerons have been replaced by doors which open simultaneously on top and bottom of the wing. Airflow is deflected from the lower to the upper surface to reduce wing lift and give effective rolling performance throughout an extended speed range.
Okay, we're ready to cycle the vertical stabilizer for full throw.
An all-movable vertical tail, another innovation, is a logical evolution of the familiar fin and rudder combination. The all-flying horizontal tail has been widely accepted in the last few years. This is the first modern application of the slab tail principle to vertical fins. The all-flying slab tail is very similar to the F-100 surface, but here too another new feature has been added. ALCS is the new element, and the initials stand for Augmented Longitudinal Control System. Longitudinal control pitches the nose up or down. This has been standard since the Wright brothers. Augmentation is the unique feature. Augment means to help, and we're helping the pilot in this instance. Using an electronic system, cockpit stick forces are always kept proportional to the pull or push exerted by the pilot. ALCS has a built-in pitch damper and has fail-safe circuitry to give the pilot positive control if an emergency arises. The last of the major tests checked out all operating systems on the aircraft. The engine was cycled throughout its operating range, and hydraulic pressure, electrical output, and fuel flows were watched carefully. Finally, the most critical test of the engine itself, full power afterburner operation. The successful completion of a group of people who had their ideas, their decisions, their efforts riding with the airplane on this trip. North American's test pilot, Bob Baker, had completed final briefing and was ready to go. Pilot and crew chief conferred on hand signals for communication through a long list of pre-flight control checks. A lineman acknowledged the pilot's signal, and the horizontal stabilizer was operated through its full travel. Then the spoiler operation. The one-unit movable vertical tail. And the flap check. When the checklist was completed, the pilot signaled for electrical pullout. An Air Force facility situated in a strategic location for monitoring test flights of aircraft was the telemetering ground station. Housing a maze of electronic equipment, this installation was equipped to track the aircraft and record vital performance data during the flight. Flight test engineers took up their special stations in separate groups for observation.
Edwards Tower, this is 118. Ready for position. 118, you're cleared to position behind the F-100.
The TF-100 took up a wing position for photo chase activity.
This is Jet 118. This is a 30-second warning for takeoff. Telemetering zeroed, calibrated, and on. I have a red light on the landing gear handle. 118, your large square door on the left-hand side is not locked. I will recycle the landing gear at a lower speed. The light in the handle is now out. Your doors are closed and locked. Roger. I'll go up in speed.
Busy crews at their stations in the telemetering facility kept constant vigilance on the flight of the F-107, receiving and recording vital performance data transmitted from the airplane itself, as well as monitoring communications between test engineers and the pilot.
Turning Alice on now. Alice is okay. Turning yellow damper on now. Okay.
Actual flight bore out the value of such engineering advances as the F-107 special features: the augmented longitudinal control system, the all-movable vertical tail, spoiler ailerons, and the new overhead duct. When all runs were completed, the pilot reported,
Item 1, satisfactory.
Air Force 55118 cracked the sound barrier in level flight on the first trip, and performance of the unconventional controls and other new features was highly encouraging. Number 1 flight, the first of hundreds of test flights to be made, improving all the features of this brand new airplane.